Consider the following statements. A minimal sufficient statistic is always complete. And the second statement says a statistic that is independent of every ancillary statistics need not be complete. So if we consider the first statement, so completeness and minimal sufficiency. So minimal sufficient means the statistic contains all the information about the parameter in the smallest possible way. Whereas this completeness means there is no non-trivial function of statistic that has expectation 0 for all the parametric values. So that means, so completeness and minimal sufficiency, they both are two different properties. So a minimal sufficient statistic need not be always complete, because there are like examples, like there are families like without a complete sufficient statistic, like uniform distribution. So where the minimal sufficient statistic is not complete. So therefore first statement is wrong. If we consider the second statement, that a statistic that is independent of every ancillary statistic need not be complete. Again, like ancillarity and completeness are two unrelated concepts, because if we consider the statistic, ancillary statistic, so we say a statistic is ancillary if its distribution does not depend on the parameter. Whereas completeness implies that there should not be a non-trivial function of statistic that has expectation 0 over all the parametric space. So independence from ancillary statistic doesn't implies completeness. So therefore the second statement is correct. So therefore option B is the correct answer.